So we go back to the history. Okay. We know that the air pressure is very high. Okay, but how high it is? Okay, and actually this problem is solved in the beginning of 70th centuries. Okay, who is this? This is 1021017千里, right? I don't know how to spell it. Maybe Torri Sari. I don't know. Okay, it's Italy. It's from the Italy. Okay, and he do a very famous experiment to measure the quantity of the air pressure. Okay, remember what experiment we do before? Hello, Japanese friend. What the experiment this guy do before to measure the quantity of the air pressure? What? Want to describe? Okay, that's okay. This guy is the student of the Galilei. Who is Galilei? Okay, and he continue this research. Okay, so let's come to review what he did before. I prepare a gas tube, a tube made by glasses. Okay, and first I add some mercury inside. Mercury is Hg. Okay, mercury, Hg. Okay, and I fill up the tube. So there is no any air inside, only the mercury inside. Then I prepare another container which is also filled with the mercury. And then I immerse the tube, put it inside. Okay, the tube is full of the mercury, but later you will see it will decrease. Okay, it will flow down. And what's the length of here, from here and here? What's the length? Remember? Okay, thank you. So it's a very famous number, right? Okay. So another question is, first, there is no gas inside. Okay. So we think the empty place there is no gas. We call this vacuum, right? So why this 76 mercury will be left? Why? And what's the meaning of this number? Okay. Yeah, this is vacuum, and I know you know why. You know the reason. So let's review quickly. Okay. No matter the tube is vertically or tilted, we measure this vertical length. It always be the 76. Okay. And you learn that when they are in equilibrium, so 2 points on the same level will have the same pressure, right? Okay, so my question is, here there's the pressure. Where is the pressure from? Now, this that point, the pressure is from the air, right? The air pressure. Okay, and the right side, the right point, pressure, we can say that, it's from the mercury. Yeah, mercury, both legs. And then these two pressure must be equal. Okay? So we know that this pressure is much easier, right? Because this pressure is nothing but defined by the force divided by area. Okay? And the force is from the weights of the mercury. Okay? And the weight is nothing but the volume times by the density. Yeah, and the volume is nothing but the area times by the height. Okay, so you see a good thing happen. There are two areas appear, so they vanish. Okay, so we can see that, we get this good. We like this. The pressure from the mercury is nothing but the height times the density. And the height is 76. And the density is about 13.6. So now this unit is French weight per square centimeters. Okay, so we get the value. I know the air pressure is very big, very high, but the value is here. Do you feel this value? Can you get any feeling from this value? It's very big or very small. Okay, I give you some hint. Now it tells us that the air pressure is about 1033 per square centimeter. Okay, okay. And if I change this unit to the kilogram unit, kilogram weight, so it's about 1 kilogram weight. Do you feel that it's very large? Now, this is 1 kilogram weight. You want to feel? It's of course very heavy, very big. Oh. Okay. So keep in mind that the air pressure is very big. How big? How big? It's about 1 kilogram weight per square centimeters. Okay? You must keep it in mind. We get feeling from this. Okay? So you can estimate. Yeah, I'm very big. I'm very fat, right? My surface area is very large. Okay, so we can estimate. For example, the area about me, maybe we can estimate about. Okay, with 100 times 100. Okay, the area. Okay. Okay. So, what's the force from the air pressure acting on me? I say, oh, 1 square centimeter, there's 1 kilogram weight. Okay, 1 kilogram weight times this. Can you feel that? Okay. This is about, at least, about maybe 10 trunks act on Earth, on me, right? Okay, so air pressure is a very large. Okay, so the third question is that, oh, we know that the air pressure is very high. So why is our body not crushed by the air pressure? This is a problem from the biology, not physics, right? Anybody want to share your idea? Why? Why the air pressure is very high and I don't be crushed? There are 10 trunks hit me, right? Hello? Any friends want to share your idea? Hi. You don't know? You can say anything.
Hello.
Okay? Don't forget. Okay. Now.
举手。
谁要讲？请说。英文吗？英文会。好，来，尽量。
There's one atmosphere pressure inside body.
Yeah, just like this. Now there's a hole. Okay. So the air pressure acts from the outside, but there's also some air inside, and the pressure is balanced. Okay, just like your body. Okay, so the next is what is the application of the air pressure? How does it affect our daily life? And this is simple, right? What's this? This is nothing but sucking this. Like this down. Now, this is sucking this. You must see this at your home. Okay, and why it can why this sucking disc can lift such a heavy thing. It's 1 kilogram. Why it can be lifted here? Why? Okay. So the same. It's come from the pressure. Yeah, we see this in your bathroom. So when you depress this, and some air will flow out, and so it becomes a low pressure, and the pressure from the outside, the air pressure is very large. Okay, so it can sustain this such a heavy thing. Okay, so maybe the Spider-Man, one kind of method to be a Spider-Man is to act this sucking disc. Okay, so another application is this strip. What is this strip? It's like picture. Okay, and now I want to ask one question. Now, this container is full of water. Okay, and there is a hole, right? There's a hole here. And my question is, what will happen when I inverse this battle? What will happen? The water will flow out?
Yes.
Ready? Okay, let's try. So, you see? Okay, it flow out first. Later, it stop. So, why? Now, because it's come from the air pressure, right? The air pressure will stop the flowing of the water. Now it's flowing because I have some force act on it. Okay, and another use is like this. This is the drip. When you are sick, you will see this in hospital. Okay. Can anybody can help me to sustain this container? So, okay, my question is, okay, there is the tube, and I will put this inside into the battle. So, where water flow, it don't flow right, it start flowing. So I will put it inside.
换个原则。
没有插错了。Okay, once again. So, please sustain this. Okay. Okay. Huh? You see the flow, the water flow out. Okay. So you see the water drip is begin, right? Okay, but we can see like this. If the first I close this, okay, I switch off the entrance, and then now how do you do this? First, one side you will put into your body, right? And another side you hand on, right? And then please tell me, you just touch here. Okay, you don't add any force. So now this water is like your body, okay, and I put inside your body. Okay, the injection stop. So I open it. So let's see what happened. Now it's falling. Okay, and what you see? You don't add any force on this. So you see that the battle, the plastic battle, begin to crash. Right? Okay, you can see the flow is continuous. So again, what kind of force act on this to crash this battle? What's the force to act on this battle? Yeah, the air pressure. Okay, but if you are in hospital, you never see this happen. Why? Because the pressure inside the battle is very low. So the air pressure crash them, right? But do you think if your blood you put into your body, the blood will flow out? Okay, so we never do this in the hospital. So if you see in the hospital, the nurse will use a needle and to give a point, give a hole here. Okay, so the pressure will become 1 atm. Yeah, the inside and the outside pressure are the same. Okay, so the blood into your body will not flow out. Okay, okay. So it's even for such an easy set, a trick, we use the air pressure. Okay, and many applications of the air pressure you can think. Okay. So maybe the time is not enough, but let's do the last part. Okay. So you know that the air is composed of many components. Right? There are many components in the air. Okay. So now you must know the answer. What kind of gas inside the air? What is the main component in the air? You can use your chemical language to tell me. What is the main component in the air? It's nitrogen, right? Okay. So I see that there are about 75% nitrogen and about 20% oxygen and other like argon and carbon dioxide. Okay. So now we want to do a simple experiment like this. We do this in an easier set. Okay, now this is a gases battle, right? Okay, and I put some tissue on here. Okay, and then I will add some alcohol onto. So remember that you should first close this set first, okay? And then I prepare some water. It's green, right? The green. And I open it just like before. We call this LiDAR, right? Okay. So first I put one side into this green water, okay, and I will fire it. Look, the wind is so hot. Okay, so it's frying. And then I will put into the container. Okay, fire stop. Okay, then I will open this set. What will happen? What will happen? So the water flow outside, and you see that the green, the water on my right side is green, and the water flow to the left side become yellow. Okay, why? What happened? Okay, the water flowing slow down. How you can see this? So the green water and the yellow water, and you can see that the water flow stop, and you can see that about 20% volume is occupied by this yellow water. Okay? Okay, so what happened here? What happened here?
二氧化碳是什么？所以心理压力。
Okay, and this guy say that because I fire this, right? I fire the tissue, and there are about 20% oxygen. Okay, 20% oxygen, and will be fired, oxidized, and going to the carbon dioxide. The oxygen will combine with the carbon, become the carbon dioxide. Okay, but we know that carbon dioxide is not bad. How to say it? The carbon dioxide may combine with the water. Okay, and it will become what happens when the carbon dioxide CO2 meet the water? What happens? What happens? Now it may become like this. CO2 and the water, H2O, will become something like this. Right? And this is some kind of acid. You give to this, right? You give it this hydrogen ion. Okay? And actually, yeah, I put something into my water to become the green color. I put this. This is called a universal indicator, but it's nothing. But you often see this in your lab. Okay, when this indicator meets the acid, it will become yellow or red. But when it emits the alkali, it will become like green or blue. Okay? Okay, so let's now do something to do this. And my first question is like this. Because there is only 20% oxygen in the air, right? So please do one thing first. Now, there is a battle. Please tell me how to mark 5 lines to get 5 equal volume. You know? Oh, now here is a battle. I want to draw 4 lines, sorry. 4 lines. Yeah, when I draw 4 lines, you will get 5 parts. Okay, but I hope to get 5 equal volume. How to do this? How to do this? You can see that this battle is different. It's not like this one. Right? This line is vertical. But you see your battle on your desk. Your battle, you take your battle. You see like its shape is something like this, right? So how can we get 5 equal volume? How to do? 听懂吗？我要怎么做可以把这个长起来胖胖不规则形状的得到5个同样的体积？
用那个时间就可以。
没有，我现在要先画4条线。I have to find 4 lines to get equal value. Okay, how to do? Don't think too difficult. If we use this, okay, because the container inside, the volume is about 250. Okay, so you just measure this and get about 50 milliliter. Okay, get about 50 milliliter, and just add inside. And this is about 20% volume inside. Okay, so first I hope you to mark 4 lines and try to do this experiment. You can open up your drip set. Open up your drip set. Okay, you open it.我们要暂停的，对不对？是吗？
他们在外面等，
哦，
差不多。
Okay,
再
so
3分钟。
okay, so you just see what's the structure of this drip set. There one side will be put a needle and put inside your body. Okay, the other side will be put on the bottle, and the water or something medicine will flow down. Okay, and the set I used before is nothing but like this. Okay. First, you can find this in the hospital or some store. Yeah, there's a needle. It's very heavy, right? And actually, this will be put into your body. It's very hot. Okay, and you can use this and push down. Okay. So some needle will come out, and this is the entrance for the water to flow from outside to into the container.
是里面还是外面？
从外面插进去。Okay, once again, because we don't have the time, maybe we don't do this. So first I use this needle. Yeah, this is like your body, and just push down. Okay, slowly. So now we get an entrance to make water from outside to flow in. You should. Oh, these are long.
不是有时候插不透，太短。
There's a longer one. You can try this. Okay, and so maybe we should stop here because you have another. Okay, and this is the Japanese drama I like very much. Do you see this? Japanese friends, do you see this? Is this very popular in Japan? Okay, okay, and yeah, actually he mentioned very many science and physics in this drama. Okay, and I hope that when you are learning physics or learning science, you can know where can it be applied. Okay, the application is very important. Yeah, and thank you very much. So let's stop here. Thank you.